Greetings, Algebra 1 people. In our previous assignments, we've been looking at factoring trinomials, and I had said, math is strange. Sometimes we teach you how to do things that you might go, what's the purpose? And then later on, we show you what that purpose might be. So I thought, well, today we're going to talk a little bit about the purpose behind factoring trinomials, and that is so we can solve them. But as I was making a video for you guys before and got into the manga high questions, they also included something that wasn't quite related to what we're doing. But I don't want to trip you up when you're going through the manga high stuff, so I thought I'd better talk a little bit about something called factoring by grouping. Now, we've been factoring trinomials, and there's really only two things that we were doing with that. We're just factoring the trinomial into binomials, and the other little piece of that was to look for a common factor before we did that. And those are two really good techniques to factor. But sometimes we have a different method for factoring, and let's take a look at how that works. Notice that I have four terms, and when I look at those four terms, they don't have anything in common for all of them. That is that my 12p to the third might have something in common with my 21p squared, and they might have something in common with my 28p, but my negative 49 over here doesn't have anything in common with those as a group. So I don't have a common factor for all the terms here, but the technique we're going to do is we're going to group things together. And so what we really do is ignore the ones at the end here and just focus on the first two. Let's group those together and see if they don't have a common factor. So just looking at the 12p to the third and the negative 21p squared, are there common factors here? And yes, there are, because if we look at just the numbers, 12 has a factor of 3, and negative 21 has a factor of 3 as well. So I could pull out a 3. That's easy enough. But that's not all, because here's a p to the third and here's a p squared. So they really have at least a p squared in common, right? So I'm going to factor out 3p squared from these two. Now, again, factoring kind of means that I'm going to divide both of those by the same number. I'm going to divide 12p to the third by 3p squared, and I'm going to divide negative 21p squared by 3p squared. So let's do that. What happens when you take 12p to the third and you divide by 3p squared? Well, hopefully you see that you get 4p. And if you don't see that, let's just go backwards here and multiply. What would you get if you took 3p squared and you multiplied by 4p? Yeah, you get 12p to the third, right? Because 3 times 4 is 12, and p squared times p is p to the third. We're going to do the same thing over here. We've got minus 21p squared. If I divide minus 21p squared by 3p squared, then I get negative 7. And again, you can double check yourself. If you took 3p squared times negative 7, you'd get negative 21p squared. Okay? Now we're going to do the same thing to the next two numbers. So we're going to ignore these first two, right? And we're just going to group the second two together and see if they have anything in common. So when I look at 28p, that's a p, by the way, 28p, and I'm subtracting 49, I think that they both have 7 in common. So I'm going to write 7 down. And then divide both of those by 7. So what's 28p divided by 7? It's 4p. And again, 7 times 4 is 28. 7 times 4p would be 28p. And if I took negative 49 and I divide by 7, I get negative 7. Okay? Yep. Now I want you to look at this problem for a second. Do those have anything in common? Yeah, they have an a in common. So, you could factor an a out of here. You could say, oh, that's like a times 3p squared plus 7, right? Because again, we could take the a out of here, take 3p squared times a and divide by a, and we'd be left with 3p squared. And we could take 7a and divide by a, and we'd be left with 7. So you could factor out that common term, that a, from both, right? Why did I show you that? Well, if you look at what's going on up here, I got a 3p squared times something. I could just call that a if I wanted to. And I have a 7 times that same something. I could call that a. So it really looks a lot like this problem down here, doesn't it? 3p squared times a, if a was written instead of 4p minus 7, and 7 times a, if 4p minus 7 was written as a instead. So we could write our 4p minus 7, or factor out our 4p minus 7 from both of these. And if I factored out 4p minus 7 from this whole term here, what's left over is 3p squared, right? And again, if I factored 4p minus 7 out of this whole term, the only thing that's left over is a plus 7. And so what I've done is I've taken this original 4-termed polynomial and I factored it by grouping so that now I have this equivalent expression. Let's do another one so we can see what that looks like. We're going to run a little bit faster this time. Look at just the first two terms and find something they have in common. 2x squared, isn't it? So I'm going to write 2x squared. And then if I factored out a 2x squared from 12x to the third, I get, what, 6x? And if I factored out a 2x squared from this term, I'd get 1, since 2x squared times 1 is 2x squared. Let's look at the second half of this. Do you see something in common between 30x, or let's say negative 30x, and negative 5? I do. I see a negative 5. And so I could factor that negative 5 out. And if I had negative 30x divided by negative 5, I'd get a plus 6x. And I don't really have to write my plus there. I know it's a positive. So to avoid confusion, I'm just going to say 6x. And if I divided negative 5 by negative 5, I'd get a positive 1. Once again, if I took negative 5 times 6x, I'd get negative 30x. If I took negative 5 times 1, I'd get minus 5. So that's what I'm doing, is taking that common factor out of there. Take a look at this. Do you see there's a 6x plus 1 that's in common? So we could write that down, write 6x plus 1. And then what would I be left with? Well, I'd be left with 2x squared minus 5. And so that's how that factors. That's called factoring by grouping. It has really almost nothing to do with what I wanted to talk about today, because what I wanted to talk about today was solving trinomials. But for some reason, Manga High decided to throw a couple of problems like that into these problem sets, and I thought you'd probably ought to see what that looks like, so that if you have one of those problems, you might be able to actually do it. But what I really wanted to talk about are solving trinomials. And again, so far we've learned how to factor trinomials, and I said we'd tell you what we're going to do with that later. And so this is the later. I'm now going to tell you how to use factoring, or why we're interested in factoring in the first place. So let's talk about trinomials. These are really second-degree equations. They're called quadratics. I know, quad means 4, and There doesn't seem to be any good reason why they'd call them quadratics, but second degree equations, things that are raised to the second power, are called quadratics. And the standard form for a quadratic is y is equal to some ax squared plus bx plus c. That's the form that we use. When we were talking about linear equations, we had y equals mx plus b. Here we have y is equal to ax squared plus bx plus c. And if we were to graph a quadratic, some function that looked like y equals ax squared plus bx plus c, what we find is it takes on a particular shape. Linear equations, y equals mx plus b, were lines. Every time we did a linear equation, if we graphed it, it was a line. You guys have been graphing lines for like 2 years. You're probably tired of graphing lines. When you get into Algebra 2, we'll teach you how to graph parabolas, which is what this is. This U-shaped thing is called a parabola, and it's the shape you get whenever you graph a second degree equation, some ax squared plus bx plus c thing. So anyways, there's 2 flavors to these. The first one opens upwards. Okay, that's why there's arrows, but it's a U-shaped thing that expands out into infinity in those directions. But the whole thing could be upside down as well. So you could have a parabola that instead of opening down or opening up, it opens down. So again, you have the same familiar U shape, but now those branches continue on to infinity in the negative direction. That's the shape of a quadratic. But what does that have to do with solving? Well, here's the idea. When we say solve, we're really talking about looking for the place on the graph where it crosses the x-axis. And I want you to notice that a coordinate system is really just 2 number lines. And those 2 number lines cross at the point 0, 0. That means that if I'm looking at the x-axis, the y-axis crosses the x-axis at 0 on the x-axis. And the same thing happens if we think about the y-axis. It's really just a number line, right? And it's being crossed by the x-axis. Where does the x-axis cross on the y number line? Well, it crosses at 0 on the y-axis. That's why the origin is at the point 0, 0. When we're talking about solving a quadratic, when we're factoring trinomials and solving them, we're interested to know where the value on the graph, this is the graph, where the value has a y value of 0. At the point where the graph crosses the x-axis, the y value is 0. That y number line has a value of 0 right here. And so we're interested in wherever this graph is taking on a y value of 0. Okay? And that happens when the parabola crosses the x-axis. So here's a place where that happens, and here's another place where that happens. The y value, if we looked at the y value of those points of intersection, the y value would be 0. Okay? Same thing happens if the parabola is upside down. Okay, same shape, but there are a couple places on this graph right here, and again on this graph right here, where the y value would be 0. And again, that's where it crosses the x-axis. So when we talk about solving trinomials, what we're really saying is, what are the x values where the graph crosses? What's the x value right there? What's the x value right there? Those would be the solutions when we set our function equal to 0. And that's what we're really trying to do. So solving quadratics means look for the places where the graph would be 0, find the zeros of the function, find the x-intercepts of the function. All of those questions, or all of those, are really the same question. We're looking for the points where it crosses. We're looking for the x values where it would be a y value of 0. So anyways, if the standard form says y is equal to ax squared plus bx plus c, then setting y equal to 0 would give us an ax squared plus bx plus c equals 0, right? We're wondering where the y value is 0, so we're going to set that y value equal to 0. How do you do that? Well, by factoring. So if I were to factor this trinomial, this is one of our easy ones. There's a in this case is 1, right? So it's going to be simple. The only way to get x squared is take x times x. And then we have to think about factors of 10. And our choices, I guess, would be 1 and 10 or 2 and 5, right? But look to the middle term. We've got to get to 11. And I don't think we can get there with a 2 and a 5, but it does look like we can get there with a 1 and a 10. And everything's positive. So I think we can go x plus 1 and x plus 10. So that's factoring it, right? But there's a 0 here. So this trinomial factors into these two binomials, but they're still equal to 0. And there's something that's called the zero product property. The zero product property says this. Imagine you have two numbers. Let's call them m and n, and I'm multiplying them. I'm going to take m times n, and I get 0. Stop and think about it. What are the possibilities that you can come up with where when you multiply them, you get 0? Well, the only time that you get 0 when you multiply two numbers together is if one of the numbers was 0, or both, right? Think of, if you plug in a 0 for m, 0 times 7, 0. 0 times 8, 0. 0 times 100, 0. As long as m is 0, it doesn't matter what you plug in for n, you're going to get 0 when you multiply. Same thing in the other direction. Suppose n was 0. Would it matter what number m is? Because you take any number times 0 and you're going to get 0. That's called the zero product property. It just says that, hey, when you multiply two numbers together and you get 0, that means one or both the numbers had to have been 0. So what does that have to do with this? I'll show you. We've got two numbers that we're multiplying and they are 0. What that means is that one or both numbers have to be 0. And I'm going to say, let's consider both cases. Let's say x plus 1 is 0. And let's also consider that x plus 10 is 0. Let's look at both possibilities. How do you solve these now linear expressions? Well, to get x by itself, all we have to do is subtract 1 from both sides. So we'll subtract 1 from that side, subtract 1 from that side, and we get x equals -1. There's one of our solutions. Let's solve this one. How do we get x by itself? Well, we can subtract 10 from both sides. So we'll subtract 10 from both those sides, and we get x equals -10. So when we're solving a quadratic, we're looking for two answers. We're looking for where the graph crosses the x-axis. We're looking for these x values where it crosses, okay? Now, this parabola isn't this problem, so don't try to look for where it go, well, x is supposed to be -1, and clearly it didn't cross at -1. I was just showing you the shape of the graph, right? And saying, here's a different trinomial that has other places where it's crossing the x-axis. It's still going to be that same U shape, whether it's going up or down. It's a U shape, and we're looking for those two places where it crosses the x-axis, and here they are. Crosses at -1, crosses at -10. Okay? Let's do another one real quick. We're solving by factoring is what we're doing. If we were to factor this, again, pretty simple, x and x, but now we got to think about 32. So our choices would be 1 and 32. 2 and 16, 4 and 8. Are there some other ones? Don't think so. But now look at the situation we have. The last number is negative, but the middle number is positive. The only way to get this negative number on the end is to have one of the numbers we're looking for be positive and one be negative. We have to take a positive times a negative in order to get a negative. So check out the middle number. Now we're going to look at the difference, because one's positive and one's negative. When you add them together, you're looking at the difference of the numbers. The difference has to be a positive 4. So it looks to me like the only one that has a difference of 4 is this bottom one, 4 and 8. And I'm going to have to use a positive 8. So I'll say plus 8 and minus 4. Why did I say positive 8? Because notice if I take x times 8, I get 8x. But when I take negative 4 times x, I get minus 4x. And if you had 8x minus 4x, you'd get to positive 4x. So that's how that factors. What do we do next? Because we're not done. What did we do before? That's right. We use the zero product property. So we set each of these factors equal to 0. That's the important part here. We've done the other stuff before, but the new thing is that we're going to set them equal to 0. So we're going to say x minus 4 is equal to 0. X plus 8 is equal to 0. And then solving, you get x. I can't write an equal sign. X equals 4. So we'd add 4 to both sides, right? And how do we get x by itself? Subtract 8 from both sides, and we get x equals negative 8. So we've got our two answers there. Again, the two places where that graph would cross the x-axis in this case would be at 4 and at negative 8. All right, let's move on and see what Manga High has in store for us now. Hopefully it doesn't throw any more weird things in, because I did this before. I mean, this is the second time I've done this video. Anywho, expand the parentheses. We've done that before. We're going to get x squared plus 3x plus 6x gives us 9x in the middle, and then we're going to have plus 18, right? So x squared plus 9x plus 18. This one. Given that x plus 1 times x plus 7 is equal to 0, remember we're going to use that zero product property that says that either x minus 1 is 0 or x minus 7 is equal to 0. I don't know where they're getting that. It should say x plus 1 equals 0 and x plus 7 equals 0. So we're going to say that's false in this case. Again, use the zero product property. If I could take 4 times x plus 3 and get 0, then either 4 is equal to 0. I know 4 is not equal to 0. Or x plus 3 is equal to 0, so that's a possibility. If we were to solve for that, if x plus 3 equals 0, we could subtract 3 from both sides, and we get negative 3. What would the value of x, or what value of x would make the expression below equal to 0? Well, I mean, again, x plus 3 squared is just x plus 3 times x plus 3. And so I'd set those equal to 0. If x plus 3 was equal to 0, then x would be negative 3. Same thing's going on here, x plus 2 times x plus 2. If that's equal to 0, then I'd have to set x plus 2 equal to 0 and subtract 2 from both sides to get x equals negative 2. Complete the factorization. These ones are easy because when you look up here, we have to multiply 1 times something to get 5. Go ahead and factor this. We know the first one's got to be x. Then we have to think of factors of 6 that add to be 1, right? Or negative 6 that add to be negative 1. So I think we're going to do x minus 3 and x plus 2. Solutions to the equation are 10 and 3, right? That's correct. And how'd they get that? Well, they set these equal to 0 and then solved them. But which other equation would have the same solutions? Well, let's go ahead and FOIL this top one and see what we get. We should get one of these. So we get x squared We get minus 3x minus 10x makes minus 13x. And then negative 10 times negative 3 would be plus 30. So we had negative 13x plus 30. That one. So here they've already factored it for us. That's nice of them to do that. So how would we solve it? Well, set each of these factors equal to 0. Zero product property. Set the factors equal to 0. If I solved x minus 3 equals 0, I'd get positive 3. If I solved x plus 5 equals 0, I'd get negative 5. So I got to go with 3 and negative 5. And here's the last one we're going to do together. If that really can be factored in that way, could we solve that? Sure, I can. 12 and negative 2. Boom. All right. So I think this video has been plenty long. Hopefully we didn't just bombard you with information. But try your hand at this. Make sure you're playing through and get plenty of practice on these so you get good at them. Good luck. Have a good rest of your week, and hopefully we'll see you soon.